All right, well, we'll kick it off with some housekeeping announcements. I know Kaio's got a lot of content to cover here, so we'll clean those up first. Hopefully everyone has by now downloaded the app and is starting to fill out the session surveys. We really do appreciate your feedback, and we do take them into account. So, you know, the more surveys we get, the better. Please provide your input. Welcome to Data Security in Practice. Another housekeeping item before we begin. If you haven't signed up for expert one-on-ones and you have burning questions about things going on in your organization using MarkLogic and things you can improve, please, the room's just right down there. We've got someone coordinating schedules and lots of folks around here who should be able to help you out. It's my great pleasure to introduce you to Kaio Milani, who's on our product management team. And hopefully you've come here with all your great technical questions. I'll be running around afterwards with a microphone for Q&A. Please do wait to ask your question in the microphone, because we are recording these and we want people to benefit from the great questions you have, because it's likely if you have one, then someone else has the same question. So the recordings and the slides will be posted online. We expect in July, so you'll get a notice about that.
And I will ask you to hold the questions to the end. I'm presenting lots of content. I may answer the questions, okay? Okay, so I'm Kaio Milani, and I'm here to talk about data security in practice in MarkLogic. I see a few faces that attended yesterday's sessions with Billy Sokol and also Ken Krupa. There were a few technical questions. This is the technical session. We'll be covering lots of technical materials. First, I want to know who is a security analyst. Okay, we have one person. Okay, that's okay, because security is a team sport. Everyone should be responsible for security. If you're a DBA, if you're a developer, you cannot let just one person be responsible for everything. And he'll be talking about all the features in MarkLogic that will help you accomplish that. And why everyone has to be concerned about security, I don't have to talk about this, but you heard so many times already in this, the threat landscape is evolving. Every week we see another hack, another problem, as well as regulation. Especially in Europe, more and more regulation coming. So you have to be aware of all the things that are going on. And especially a problem when you're integrating data. You're putting all your eggs in the same basket. You're doing your data hub, your data lake. You better have enterprise security there. And MarkLogic delivers on the enterprise-grade security, and that's the topic that I'll be talking about today. I'll cover all the areas about security in the product. And before I start talking about a product, I want to introduce a model that I will use throughout the presentation, which is the CIA model. Confidentiality, integrity, and availability. Last year, I did a presentation in MarkLogic World about availability. I'll be not covering this today here. You can watch the video from last year. Today, I'll focus on confidentiality and integrity. I have a few examples of features. This is not an exhaustive list, but a few features that you can think of. What is confidentiality? Oh, the data is encrypted. Integrity, I track changes, I know who did what, okay? And availability is the resiliency of MarkLogic. So MarkLogic delivers on the CIA model with a granular security model. We already have, for many years, role-based access control at the document level. In 9, we introduced at the sub-document level. I will explain in details both. We have strong authentication and authorization. We already have encryption in transport. And we introduce now at REST, and we have robust auditing. And it's not me, the product manager, that is telling that we are enterprise grade. We are actually certified. We are the only NoSQL database that is certified. And we are actually certified for use in government. We have been used in highly secure environments for many years. So now I want to go over many use cases about how to secure data in MarkLogic. So the model here, I will explain a problem, and I will describe what are the solutions to solve that problem. The first one, the basic here, okay, how do I control access to documents? Some other databases don't even have the concept of controlling access to documents. We are far ahead of that. So we are at the document, and I'll get to subdocument. But let's first get to the first thing. And in order to control access, a few questions that we need answered here. Who's the user? What should the user see or do? And finally, we have to monitor that activity to ensure that we don't have permissions that the user shouldn't have, okay? So we'll be talking about AAA. What AAA means, and a hint, is not an insurance company. Who can tell me what AAA means? No. Authentication, authorization, and auditing, okay? So first, let's start with authentication. So we have local or delegated. Local, you create all the users. Everything is inside the product. You're not relying on an external authentication provider. Delegated is when you're using LDAP or Kerberos. So we already support this for some time. In 9, we introduced a few other things here related to authentication. First, certificate-based. You can use a certificate to authenticate or certificate plus password. This is great, especially when you're doing scripts that you need the script to authenticate, so you can have the script using or your APIs using certificates to authenticate. We started our support for SAML. If you are interested in SAML, I recommend you to read what we did in 9. And it's not the full implementation of SAML, but it's a good start. We have that functionality. And finally, we have the ability for you to store credentials encrypted. Let's say, as a data hub, you have to go and talk to other systems to get content. Now you can store in MarkLogic the credentials to log into those systems in an encrypted manner, because now we have encryption, and I'll talk about that. So that's the first part. What is authentication giving me? Telling me who's the user. First question that I have there, who's the user? Second was what the user should do. And MarkLogic controls that using roles, compartments, and privileges. And the DBA doesn't need to be root to the OS. I'll get in detail about how we do that. And I'll use an example here. And throughout the presentation, I'll be using the example of an insurance policy. I have 2 users, and each user has a role. So we have a user with the compliance role and another user with the call center role. I have that insurance policy, and I have what we call permissions. A compliance role has the capability of reading and updating, but the call center role can only read, okay? At this point, it's important to understand this is an or. So or I have the call center, or I have both, or I have the compliance. In all scenarios, I can read the document, okay? So this is the basic. But I understand that there may be folks here that are already familiar with this, so I have some advanced concepts. But I will warn you, those are kind of mind-blowing. I do not expect you to understand. So this is we're getting into advanced, but I will explain those. And later on, you can revisit this material. So I said that those roles was an or. So or I have one, or I have another. Let's say those were insurance policies created in the UK, and I want only someone from UK to see the document. Compartment security allows me to create an end. So I have to have one role plus other roles in order to see the document. So that gives me this ability. So it's an end on roles. It's a complex concept. I understand that. Second, protected collections. That will help you on data quality and provenance. You create a collection. Collection is a way to group and classify documents in MarkLogic. A protected collection is a collection that you specify which roles are required for someone to insert documents there. Let's say I have home insurance in UK. That's my collection. I only want someone with those roles in order to insert documents. So that prevents someone without those roles from inserting the wrong documents there. So if you're doing reports, you know that only the right people inserted documents there. This is not changing the permissions on the document. This is you have to set the permissions. Final advanced concept about authorization here, whole hierarchies. My example here, I created European Union. I have, I think, 22 countries there. The idea is we have many support cases about customers. Oh, I need to update security. And when you update security, you are actually updating the document. Security lives with the document in MarkLogic. When you have a hierarchy, when you are creating an abstraction layer between the document and the roles, when you change that abstraction, you are not touching the document. Okay, so think about, again, revisit these concepts. It's important to think about whole hierarchies as a way to be prepared for change. What is the change that will happen in about 2 years? The UK will leave the European Union. I just removed that role. I don't touch a single document, and I cannot see those documents anymore. Okay? Again, advanced concepts. I do not expect everyone to understand those. Auditing, the final part of AAA, excuse me. Every activity that happens to documents, such as reading, updates, we can log those. You just enable those. And you can figure out, for instance, if a user is overusing his ability to read documents. So you should monitor our logs. And we also, every change that happens to the server, like an admin performing changes, we also log all those changes. Okay? So that was the first basic problem. But you may be thinking, okay, I have all that authentication, authorization, but can I bypass that? Yeah, there is information on disk. Is the information on disk secure? Can I guarantee that nobody can read from the disk? Can the cloud admin see the information? Can someone modify the data on disk? Or finally, I have the logs. I just told you about all the auditing. How can I prevent someone from deleting a log entry? For instance, I deleted a document and I go there and delete my activity. For that, I'll be talking about encryption. As I already said, we already have encryption and transport. Today, I'll be talking about encryption at rest, which is the ability to encrypt data, configuration, and logs. First, it provides protection about insider threats. I'll explain how we get there. Second, better governance, because it prevents you from tampering information or modifying logs, or even getting information about the system. We also encrypt the config files, so you cannot even understand how MarkLogic is configured. And finally, there are many mandates now that demand that you encrypt data, so you can meet those mandates. Going back to my CIA model, encryption helps on both this confidentiality and integrity. First, the confidentiality piece. My illustration here, once I encrypt the data, a sysadmin or a cloud admin has no way to open the files and get any sense of that. Those files are encrypted. So only the DBAs or who has access to data will be able to have access to data. So that's providing confidentiality. So for instance, that allows you to deploy MarkLogic in the cloud in a safely manner. In the second, in the integrity part, two aspects. First, the data. If the data is encrypted, you cannot modify the data without the keys. You can corrupt the data but not modify. So MarkLogic will know that you corrupted the data. And also because we encrypt the logs, you cannot erase any traces of wrongdoing. You cannot go there and erase an entry, right? The log is encrypted. So this is very important for you to have proper auditing and understand that everything is logged and accounted for. The solution is transparent encryption. You select which databases you want to encrypt. You select if you want or not to encrypt logs, configs, and backups. And it's called transparent because it requires no modification to the application code. It's an activity that the DBA will turn it on, and it will select what areas he wants to get encrypted. We support two ways of doing key management, the local or the external. That's my illustration here. Local, all keys are generated by MarkLogic. External, we rely on an external key management system. I will get in details about why to use an external key management system in a few slides. Question that I got, I think, twice today already, performance. Two scenarios here. If you're using local encryption, we did performance tests in Amazon and 2 to 3% performance degradation, very small. When you rely on an external entity, since we have to communicate with that entity quite frequently, probably 7%, 8%. But there's a trade-off here. Yes, more performance degradation, but it's more secure as well. Talking about security, when we were designing this feature, we thought about leveraging the capabilities of MarkLogic. So I'll use the illustration to explain how we encrypt data configs or logs. So every database is composed of forests, which is composed of stands, and stands are a few files. Every file that we save to disk, we will generate a new key. That is the lowest level key. That key is generated by MarkLogic, so here represented by the blue key. We save that key in what we call an envelope, which is a key encrypting another key. In that case, it's the fast rotation key. And the name implies this is for key rotation. And then the fast rotation key I encrypt with the data key. That means that every file saved to the disk in MarkLogic at the lowest level is encrypted with a different key. So if someone is able to compromise the data by doing dictionary attacks or things like that, it's only compromising a tiny amount of data. So this is a highly secure design. And you don't have to worry about the low-level keys. You just have to worry about the data key. How the external KMS helps or works here. We have the internal KMS, but the advantage of using an external KMS. So I said that we have that envelope. So my fast rotation key is encrypted. When I want to start the database, MarkLogic will communicate with the KMS, will send the envelope. Only the KMS has the green data key. MarkLogic will never have access to the green data key. The KMS sends back the fast rotation key. At that point, MarkLogic can open the stands. Every time they're generating a new file, we'll ask the KMS to create a new envelope. That means that if you try to move data around in the data center and you move to a server that is not authenticated with the KMS, you cannot open the database. That's why it's highly secure. The server has to be authenticated, the birth-in certificates, and so on, in order to open the database. But because there is this communication, that's why there is some performance degradation. But this is highly secure. And if you think about deploying in the cloud, you can own all your KMS, and Amazon or Azure will never be able to ever open your database. This is probably another advanced concept. So, okay, if you don't understand here, so revisit this later. Rotation. We have the envelopes and we have the low-level keys. MarkLogic has to therefore rotate both keys. Here in my illustration, I'm rotating the top-level data key. Rotation, the frequency of rotation is kind of a factor of how easy it is to forcibly decrypt a key. The recommendation from the National Institute of Security Standards, NIST, is 2 years, because that's, with current computing, you probably take 2 years to break the key. So every 2 years, you have to rotate. It's very simple to rotate in MarkLogic. You create your new key, you type the new key ID, MarkLogic will do the handshake and get the new envelopes. Why it's a fast rotation? Because we're saving at that point tiny amounts of information in its stand. It's just the envelope. So you can do this quite frequently if you want, but the problem is managing the keys, because you will have in your KMS too many keys if you're doing that too frequently, okay? So yes, you can do all the time if you want, but the recommendation is to do every 2 years. And then there's the low-level key. The recommendation today is every 7 years, because it's really hard to rotate low-level keys. But MarkLogic has a tremendous advantage here. Every time that we are doing a merge, we are generating new stands and deleting the old stands. So we are all the time rotating the low-level keys. And if you really want to force, just trigger a merge. It will rotate all keys, and you're getting better performance because we are compacting the database. So but naturally, all the time, it's rekeying the low-level keys. Third problem here. Okay, so we talked about controlling access to documents. But what if parts of the document I have to hide from certain users? So first question, what parts? How do I define what parts of the document I want to hide? how do I control search on that? How do I ensure that you cannot even search for things that you shouldn't see? And the final question, how it's fast and secure. Why I have that question there? Because we are already doing this for customers. We have been doing this for a few years, but with custom code, custom UDF functions. What we did in 9 is incorporate everything that we did for those customers to make it much faster and much more reliable. Okay? So we'll be talking about the feature that is called element level security. It allows you to control access to parts of the document, controls who has ability to see sensitive information inside a document. It's out of the box, it's in the database. You don't have to write special code anymore to get this capability. And it works with your evolving schema. I'll explain a little bit how you could achieve that. I was just talking to a customer in my expert one-on-one documents. There were 20 megs, lots of information. That's an insurance company. So imagine the amount of information that they have in a single document. And they do have this problem. Some parts of the document they don't want to show. So you still will be able to have that long document that contains all the information that you need. But depending on the user, this is based on the user role, the user will see or not parts of the document. So this is role-based. And it works in search, queries, and updates. If I should not see that in the document, I cannot also search that information. Okay? How do you define what you want to hide? We call it a protected path. It's very similar to the document model, but now you are specifying the path. My first example, I have //SSN. That means anywhere in the document, if I have an element or a property called SSN, I will require the HR role in order to read. If I don't have that role, I cannot read that part of the document and any child of that element. I can have more complex expressions like FN matches, using, for instance, my example is using attributes, so XML attributes, or I can even use properties, and I will show you in an example. And finally, another example using properties here. So it's the same thing that we had for documents, but now you add the path. First, you have to see the document. If you don't have access to the document, you cannot even see anything. But then we will check the paths if you have permissions to see or not. As I said, this is enforced at the core of the database. And it's made to be fast. How we do that? When you ingest a document, we get every word that is protected in a protected path, and we hash those and combine with the hash of the roles associated with that path. We just saw the expression. And I store that in the index. When a user logs in, we'll get the hash of the word that the user is searching. For instance, I'm searching for secret. But check it out. I don't have the TS row. I have the U row. We will put that in the query plan. And of course, we will not find the information. And when I try to search, I will have 0 hits. And when I try to get the document, we remove that part of the document. Everything is enforced at the document, at the database, in memory, in a way that is fast, because we're doing all these hashes. So it performs well. Okay? Enough of talking. I'll continue talking enough of slides. That's what I meant. I will do a demo now. Let me just explain what I'll do, so it's easier for you guys to understand what I'll be doing in Query Console. So I have my insurance policy, and I have 4 parts in my insurance policy. I have the client information, I have some SSN information, income, and the policy itself. It's about a home, it has some premium, it's based in dollars. My document is describing how it should be protected. I have that thing called access. That's what I chose to tell how the document should be protected. This is what in XML it's called markings. I'm showing on purpose a JSON to tell you that you can use across JSON or XML. There is a standard written about this. And all those in healthcare, HIPAA actually is coming up with the same standard, right? There is a NIST 800 for healthcare that will tell that you have to describe in the document how the document should be protected. So I have my example here. So I'm saying you need a US read in order to read. This is a US policy. In order to read that part of the client, I need ID read, and keeps going, okay? What I would do, I will create 4 protected paths. And I'm saying that in order to read, for instance, the client SSN, I need the compliance row. In order to read the parts that have risk, I need the risk row. For instance, the info and the client income. And I'll create 3 users. The call center will only see the document and the top part. The financial risk officer will only see the financial information. He's just doing analysis. He doesn't need to know who's the customer. And finally, there's a compliance admin that has to check, is this SN correct? Is everything there? Okay? So let me now move to Query Console. Okay, so first step here, I'll be creating the roles. So simple, I have the US read, the ID read, the compliance, and the risk. 4 rows. This is live. It's not, no recordings. So everything can fail. So now we'll create the users. Remember, it's row-based. So the user here, the call center, has only 2 rows, the US read and the ID read. There is only one user that has all 4, the compliance admin. So he will be able to see everything. I will insert the document, the same document that I showed you, okay? And we talked in the first part of the presentation about permissions. So this document requires US read for someone to read the document. Okay, so now my document is there. I will create the protected paths. I on purpose created 2 examples here. The first example, I'm using the markings. So I'm using the property of a JSON property to identify the path. I'm showing that this is my recommendation. You should mark your documents, and you should create paths that use the markings. But my second example, I'm saying you don't need that. It's not a mandate. It's a recommendation. Okay? But what each one is doing is telling what is the path and what is the row required. Okay? ID read, compliance, and risk. Remember that I said we did it fast. There's an optimization. I have to call a function that will optimize the rows to make it fast. And now I will call a function that is just retrieving a document, cts.doc_URI, but I'll call with different users. So I'm using some indirection here in JavaScript to call that function. What I'm really doing is calling the function with 3 users, and I'm not using eval on purpose. Eval is not good, so I recommend you to not use eval. Eval allows someone to inject code. The way I created here is impossible to inject. So what we expected to see? The call center user only sees the top of the document. The financial risk officer, only the financial aspects of the document. And finally, there is one user that can see everything, the compliance admin. Same document, I just run the query with 3 different users. Okay, so now we know how to control access to documents. We know how to ensure that the information on disk is secure with encryption and my logs are secure. Now I want to share information. Okay? I want to share. I want to send information to another group in the company or to another system or to my Hadoop cluster for my data scientists to work on those. Or I want to generate samples. Or I want to send data to MarkLogic. Jim Clark just said, send data to MarkLogic. Use Redaction, which is the feature that will allow you to redact and change the data so you can share data in a secure manner. So it allows you to export doing masking or concealing. So it's slightly different than element level security. It's more powerful in what you can do. And it's based on policies. Element level security was based on user roles. Given my role, I see documents or not, and I see parts of the documents or not. This is based on policies. And again, it's in the database, it's out of the box. Works across XML or JSON, elements or properties, and even in free text. Even text inside the element or the property. You can find information there and hide. You will combine all the rules, and I'll explain what rules are, into policies. So you may have a policy to export data to data scientists, to send it to your Hadoop cluster, another policy for your developers, another policy for MarkLogic. I need to send data for MarkLogic to understand how I'm using MarkLogic, and so on. And out of the box, we ship with many functions for you to conceal, create random data, and so on. Example here. Have a document, I changed the name using a dictionary, I created a random phone number, we have that function, we masked partially the SSN, and we created some fake data for address, the entire address. How it works. First, you create rules, and rules are based on the same concept. How do I find the information? I specify the path. So my path there is client. And I'm telling what to do. I want to mask random, and I'm specifying a size. There are many other options. I'm just simplifying here. I can specify you if you want alphabetic, numeric, and so on. And I put my rules in a collection. My example here, I'm creating rules for developers. Okay? They want to see some information, but they cannot see the real information. Multiple rules into a collection. You can reuse the rules and put them into different collections. So let's say you create a rule for SSN, you can reuse that rule in many collections. The functions out of the box, first is concealing. Just hide the path in all child elements. We have masking, which will generate random data, deterministic data, meaning that given the same input, we always generate the same output. Why you need that? Let's say you are doing joins using client IDs. You don't want to have the original client ID, or let's say the SSN, but you need a way to join. So we generate a string that is the same, given the same SSN, but you cannot reverse back, okay? We have pattern matching, like social security number, US phone number, regex expressions. You can create any pattern that you want. And you can always write your custom function, okay? We have a function called RDT_redact, and that function is there for you to primarily test the functionality. Highlighted there, I'm saying RDT_redact is not a way to control access to the information. The rules that you create in redaction are not preventing from one who has access to the REST interface to query, okay? Have in mind that this is mainly, the main goal is when you're trying to export. Having said that, I had a conversation about a customer that wants to allow users to search but not see the documents in the way they are. So you could use, if your scenario allows you to search whatever they want, but when the document is retrieved, you want a mask, you can use RDT_redact. But RDT_redact is not controlling search, okay? The rules are not controlling search. Another demo. Let me explain what I will be doing again. Same policy. I will create some rules. First, a random name based on a dictionary. I'll explain what is a dictionary. Some random number for the premium. I'm hiding some information. A full random social security number. And a random number for asset value. Okay, first part here, I'm creating my rules. And rules, they go to the schemas database. When we created this feature, we thought about the person that created the rules may be different from the one that executes. So if you do not have permissions, you cannot even change the rules. So that guarantees that the person that created the rules ensures that they are working. I'm creating a rule based on client name. I'm saying mask random. And I'm saying, as an option, use this dictionary. Again, keeps going, a random number for premium. Hide the last, so the function is called conceal. So let's insert the rules. Second thing, I need to create this dictionary. So what is a dictionary? It's a simple file. I have here in JSON, it could be in XML. Flat list of names here. Going down here, I have my other dictionary that I'm using for countries and so on. It's very simple. If you download my code, you can reuse this. So I will insert my dictionaries. Again, the dictionaries are going to the schemas. So whoever creates this, you need a permission in order to modify. Okay, now I will redact. I inserted all my rules into a collection that I call developer. And when I call redact, I'm calling, again, rules here. It's the parameter that I'm passing. And the docs, pretty much I only have one. So I will redact my document. Okay, so you can see a different name, social security number. If you paid attention, my redaction rule for name was mask random. What will happen once I click it again? Different name. The same would apply for SSN. So the example that I created here, every time that I run, there's different results. Not good for data analysis, okay? But it's great for developers. You just want to see names. You just want to test some queries, okay? So think about what is the goal and use the proper function. Okay, so we talked about how to protect access to the document, sub-document level, ensure that nobody can tamper with the documents on disk, how to export data, share data securely, hiding PII. The last aspect of the compliance and the security is how do I prevent change from data? So we already talked a little bit about how do I prevent data change from data on the disk. But there are other aspects about, okay, I have an insurance policy, and I need, by law, to keep that insurance around in the database, and nobody can modify after it expires for 7 years. The same applies to HR records and lots of other records out there. There are mandates. How do I guarantee that what is in the database will not change? How can I prevent even the DBA from overriding this? And how can I prove that it was never changed? For this, we'll be talking about Compliance Archive. Compliance Archive is a solution based on our existing temporal collections that allows you to retain documents according to regulatory needs. I'll talk about the two ways you can do that. It also guarantees that once you generate a report, that report will always be the same. While the documents are protected, the report is always the same. So you can go back in time and generate the same report. And block modifications at the core. This is enforced at the core of the database. And you continue to run the database on regular read-write storage, but we also integrate with warm device, read once, read many storage devices, as I will call the ultimate protection. You have everything running in MarkLogic, and you will have a copy, and those copies are linked. And if you need to compare those and prove, you can do that. So what it does, what is protecting a document? There are two ways of protecting a document. The first is time-based, and the second is event-based. I will start with the time-based. It's a little bit easier. My insurance policy. I want to protect against deletes for 7 years. I just tell that to the database. The database will prevent deletes from 7 years. The second one, there are many scenarios, and my example that I have here is the employee. Why I am an employee of MarkLogic. MarkLogic, by law, has to have all my records. They have, if immigration officer shows up, they have to show all my I-9s and things like that. So they cannot delete. But they don't know for how long they have to keep. I'm an employee. While I'm an employee, or while I'm a patient, while I have insurance, while I'm a client of a bank, that information has to be there. But once I leave, once I no longer have my insurance, then I have a period of time for which I have to keep that. So first, I have this event-based. I don't have a date. But when the event, in my case here, the employee is terminated, now I have to ensure that there will be no modifications, the employee is gone, nothing should change there for 7 years. See that we have different levels, no deletes and no updates. And I'll show in my demo what it means. You can only extend. For instance, you can go from 7 to 8 years. Why you would do that? You are going to an audit event, so you have to guarantee that the documents are around. Or, as I exemplified, you can go from no deletes to no updates. Okay? Out of the box, the admin cannot override. Some customers during early access ask, no, we need to be able to override. Okay, there is a way of, when you create the collection, to create a permission to override, a privilege, excuse me. Out of the box, nobody can override. The temporal, for those that are familiar with temporal, all the metadata about temporal, it's outside the document now. So if you hash the document, it's consistent. The hash that was before will be the same, and I'll show you that as well. And combined with encryption, you cannot modify on disk. All the REST interfaces do not allow you to modify, and pretty much it is, or query console, whatever you're trying, will not allow you. So you can guarantee nobody can do from the disk, and nobody can do from MarkLogic. And since we have all logs encrypted, everything that happens, you will be able to know. Bitemporal was a feature of 8. In 9, we introduced unitemporal. Unitemporal is only one access, and it helps you answer that question. When you find out a problem, when you find out about that new customer, bitemporal allows you to know when it happened. Most customers will be okay with unitemporal, and my example will be about unitemporal. You can version unitemporal documents or bitemporal documents and have now URIs. Let's say you have version 2. Forever, you can point to that URI. Forever. If you put that, if you export that, if it comes out of the database, it's the same URI. You can refer to that version forever. Okay? So that allows you to, bitemporal allows you to generate reports that are consistent. If you protect the documents, you generate a report today or 2 months later, the same report will come out. And finally, we integrate with WARM. Okay. Why we integrate with WARM? I told you, you cannot modify the documents, but somebody can destroy the database. Somebody can corrupt the database. In order for you to protect against that, once you protect documents, you can, at the same call, copy them to the WARM device. And we integrate with 2 vendors, NetApp and EMC. The protection that you set here will be the same set there. So if you tell 7 years here, we'll set for 7 years there. So you have the insurance policy. You know, if something goes wrong, everything is in the WARM device. And because we have links, we have the paths, you can prove to an auditor that the information that I'm querying here is the same that is in the WARM. I can hash both and compare. Because we're still running on read-write storage, it's much faster, it's much cheaper, you can scale. Okay? Okay, final demo. I did some preparation to create my temporal collections here. I'll start from 0, and I'll clear my database. And I'll have the same document that we had before. The difference now, I'm doing a okay. I'm doing a temporal insert because of the resolution you cannot see here. So I'm inserting this document into my temporal collection. And now I'm protecting. It's the same document. It's in the demo collection. Because by law, I have to keep this document for 30 seconds, I will tell that for the next 30 seconds, there will be no updates. So here in my database, I have this document. And if we take a look, it's a temporal document. So I know when I inserted that document into the database, and it's still valid. Okay? So I will protect the document. Let's take a look at what is happening now. I have new properties here. Now the document is protected against updates, and there is an expiration time. Let's try to do an update. I'm trying to do an update here. Oh, denied. I'm running as admin, and I cannot update the document. Okay? Cannot update the document. So until that clock that we just saw here expires, which will be in a few seconds, I cannot do anything to that document. So let's try again. Successful. So it expires. After it expires, I can do updates. Okay? Another question that we got a lot. Okay, once it expires, I also have a mandate to get rid of those. So I have a simple function here, is just finding documents that expired and deleting them. Okay, my database is now clear. Okay? So we saw all the capabilities related to security and compliance. We started talking about AAA, not the auto insurance company, but authentication, authorization, and auditing. We talked that we have LDAP, Kerberos, SAML certificates. Talking about some advanced concepts about compartments and the fact that we encrypt logs. That is important for auditing. Then I talked about encryption. I explained how we do different from other databases, highly secure. We also talked about why use an external key management system to even get higher level of security. We talked about, okay, we have documents now in 9, subdocument element, access control. And I showed that, okay, that //SSN, no matter where that SSN is, we will find. So if it keeps changing the model, if you put envelopes, doesn't matter, we'll find that information. And it's enforced at the database. You don't have to write any application code for that. We talked about sharing data using our policy-based redaction. You can have multiple policies. And finally, we talked about the same database that is providing compliance. Today, typically you have to rely on another database or solution, typically not a database, another database to store the documents. And you cannot query those documents. So now, it's the same solution. You can query, you can come up with reports, and you can tell your auditors, you can trust, nobody can modify those documents. And I can actually prove, because of the warm integration, if there is any event. I know I talked a lot. I covered a lot of ground. First, we'll point to the documentation. We have great examples, lots of code there for you to play around. We have white papers about the compliance aspects. We have videos. I wrote 2 blogs. One explains the hierarchy, and the other explains element level security. Those are links, okay? And I have a workshop today. I believe we still have a few spots available that you can actually play with the features, okay? But the workshop, after we do the workshop, will be available online, so you can download and go through and learn a little bit about these features using query console and the examples. With that, open to questions.
All right, we've got time for a question or two.
So in ML9, is compartment security generally available, or is it still restricted to certain groups?
It's licensed, but it's generally available. As long as you get the license, it's generally available. Anyone can have compartment security.
So you said that security information is included in document. What does it mean? It means that each instance of document, like for example, if I have 10,000 claims and I'm an insurance company, so each claim will have its own security information, and if later on I would be making any change, like additional role we are adding, we are going to modify those 10,000 documents?
If you want to add a particular role to all those 10,000 documents,
But why is that? Why we are not keeping this separate? That so each instance of the document would not be need to modify. Like we can put it
the
in.
assumption is MarkLogic is an elastic database, so forests can move around, and you can mount forests anywhere. So the security information does not live in a separate database; it lives with the document. So when we read that, that information goes to the indexes. It's part of the resolution of queries. When we resolve queries, we are combining the information that we read from the documents. And it lives with the document for this aspect of elasticity. So you can move a forest anywhere, it's there. That's why. And that's why I said, think about hierarchies. So you may avoid that case that, oh, I don't need to touch the documents, I just touch the hierarchy.
Okay.
With my blog, I explain in detail that.
Okay, and the last thing is about the rotation key. So rotation key, does it mean that my document will keep updating every time?
No. So the high level, which you are recommended to do every 2 years, is not touching any document, okay? The low level, it's a merge, but when we are merging, and we are merging all the time, we are re-encrypting and regenerating keys. If you force a merge, you are re-ingesting all documents, okay?
All right, last question here.
So the pattern matching that you explained for redaction, will I have a similar pattern matching to protect a data which is kind of code value pair? So SSN is not named as SSN in the element, but it is a code value. It's a code and a value. Can I do a pattern matching and then control the access?
Yeah, so what we have out of the box, the function that is called SSN, is actually doing pattern matching on the SSN pattern. Doesn't matter the name of the element of the property. Anywhere in the text of that, or even the child's, of the path that is specified, if you find something that has the 3-2-4, we'll mask according to what you told. So out of the box, we do pattern matching on SSNs, independent of paths, okay?
All right, that's all we've got time for. I'm sure everyone has lots of questions.
Yeah, I'll be here.
Here's
And-
Kaio. Thanks so much. Great session.